What is the working principle of a radar level transmitter? It measures the time taken for a microwave signal to travel to the product surface and return. This is known as the time of flight (TOF) principle. The transmitter then calculates the distance and converts it into an accurate level measurement. What are the two main types of radar level transmitters? Non-contact radar (NCR), guided wave radar (GWR). Non-contact radar uses free space microwave signals, while guided wave radar uses a probe to guide the radar pulse. What is the null zone blocking distance? The null zone is the area immediately below the antenna where the transmitter cannot accurately measure the level. This zone should always remain free from the measuring range during installation. Why is the null zone important? If the product enters the null zone, the transmitter may display unstable, inaccurate, or full-scale readings. Proper installation helps ensure the maximum measuring range is available. What is the typical output signal? 4 to 20 mA with HART communication. The analog signal represents the measured level, while HART provides digital communication for configuration and diagnostics. What is HART communication? HART is a digital communication protocol that works on top of the 4 to 20 mA analog signal for configuration, diagnostics, and monitoring. It allows maintenance engineers to access detailed device information without interrupting the measurement signal. Why is a HART communicator used? It is used to configure the transmitter, monitor process variables, perform diagnostics, view the echo curve, perform echo mapping, and troubleshoot faults. It also helps verify transmitter settings without removing the instrument from service. How do you connect a HART communicator? Connect it across the 4 to 20 mA loop or across the 250 ohm load resistor. A minimum loop resistance of approximately 250 ohms is required. Always connect the communicator while the loop is energized for proper communication. What can you check using a HART communicator? Process variable (PV), loop current, echo curve, diagnostics, device status, tag number, range, damping, alarm settings. These parameters help identify both configuration errors and process-related issues. What is loop checking? Loop checking verifies that the transmitter, field cable, junction box, marshalling cabinet, DCS or PLC, and operator display all transmit and indicate the correct signal. It confirms that the complete measurement loop is functioning correctly from field to control room. How do you perform a loop check? Inject 4 mA, 12 mA, and 20 mA using a loop calibrator and verify that the DCS or PLC displays the correct values. Any deviation indicates a wiring, scaling, or instrument problem. How do you verify the transmitter output? Measure the loop current using a multimeter or loop calibrator. Compare the measured current with the expected level value to confirm proper transmitter operation. What should the output be at empty and full level? Empty level 4 mA, full level 20 mA, depending on the configured range. Intermediate levels should produce proportional current values between 4 and 20 mA. What is echo mapping? Echo mapping teaches the transmitter to ignore fixed false echoes caused by tank internals. This improves measurement accuracy by allowing the transmitter to focus only on the true product level. What causes false echoes or weak echoes? Tank nozzles, agitators, ladders, heating coils, tank internals, dirty antenna, heavy vapor or foam, low dielectric products, Long measuring distance. Identifying and eliminating these causes is an important part of radar transmitter troubleshooting. What is damping? Damping is a time filter that smooths fluctuating level readings and provides a stable output. Increasing damping reduces rapid fluctuations but also slows the transmitter response time. What are the routine maintenance checks? Inspect wiring and cable glands. Verify the 24 volts DC power supply. Check grounding. Clean the antenna. Inspect O-rings and gaskets. Review diagnostics using a HART communicator. Perform a loop check. Verify accurate level indication in the DCS. These routine inspections improve measurement reliability and extend the life of the transmitter. What should you check if the transmitter outputs 3.6 mA or 22 mA? Check device diagnostics, power supply, wiring, process conditions, configuration, sensor or electronic faults. These outputs usually indicate a fault condition. Refer to the manufacturer's diagnostic manual to identify the exact fault code. The HART communicator cannot communicate with the transmitter. What will you check? 24 volts DC supply, 250 ohm loop resistor, wiring polarity, loop continuity, HART address, device status. Also verify that the communicator supports the transmitter's HART revision. The radar transmitter shows an incorrect level. How will you troubleshoot? Check actual tank level, echo curve, false echoes, antenna contamination, MP full calibration, tank height configuration, product dielectric constant, foam or vapor, antenna alignment. After correcting the issue, verify that the transmitter reading matches the actual tank level. The DCS reading differs from the local transmitter display. How do you rectify it? Verify loop current. Perform a loop check. Check DCS scaling, LRV-URV. Compare the HART PV with the DCS value. Inspect the AI card and wiring. This helps determine whether the fault is in the transmitter, wiring, or control system. What should you check before replacing a radar level transmitter? Verify the 24 volts DC supply. Measure loop current. Review HART diagnostics. Check the echo curve. Inspect wiring and terminals. Verify process conditions. Confirm the transmitter is actually faulty. Replacing the transmitter should always be the last option after completing these checks. How do you verify calibration after maintenance? Compare the transmitter reading with the actual tank level or a known reference and verify the corresponding 4 to 20 mA output. Record the results to ensure the transmitter meets the required accuracy. Real-time scenario, a tank level suddenly changes from 40% to 95%, but the actual level has not changed. How will you troubleshoot? 1. Verify the actual tank level. 2. Check the local display. 3. Connect the HART communicator. 4. Review diagnostics and the echo curve. 5. Inspect for false echoes or antenna contamination. 6. Verify loop current. 7. Perform echo mapping if required. 8. Check DCS scaling. 9. Monitor the transmitter after corrective action. Finally, confirm that the level reading remains stable during normal process operation. Real-time scenario, after replacing a radar level transmitter, the local display is correct but the DCS shows 0%. How will you rectify the problem? 1. Verify the 24 volts DC power supply. 2. Check wiring polarity and terminal connections. 3. Measure the loop current. 4. Perform a loop check. 5. Verify the DCS, LRVURV configuration. 6. Confirm the HART configuration. 7. Check the AI card configuration. 8. Confirm normal operation before handing over the instrument. Always perform a final functional test and obtain operator confirmation before completing the maintenance work. Thanks for watching. Please subscribe, like, share, comment. IIQA